Welcome to the Deep Dive. Glad you could join us.
Great to be here.
Today we're tackling something huge, really cosmic. Can humans actually, live on Mars?
It's the big dream, isn't it?
It is. And you, our listeners, sent over some really great material on this, so we've done our homework, dug into the science behind it all.
Yeah, looked at whether Martian living is, well, feasible science or just staying in the realm of fiction for now.
Exactly. So, cutting to the chase. Based on the science, what's the verdict? Are we talking pipe dreams or actual blueprints here?
Well, Mars definitely pulls you in. It has this potential, right? It's often called Earth's sibling planet.
Sibling, yeah, because of the similarities.
Precisely. The day length is almost the same as ours, just under 25 hours.
Hmm.
It has seasons, axial tilt. We see polar ice caps.
And signs that water used to flow there?
Huge signs. Plus, it's rocky, not a gas giant, and relatively close. So naturally, it's where scientists look first for off-world possibilities.
Okay, so it's got curb appeal, astronomically speaking. But reading through the materials, the dream bumps up against some pretty harsh Martian realities.
Oh, absolutely. Let's not sugarcoat it. The challenges are enormous.
So what are the big ones? The showstoppers.
Top of the list, the atmosphere, or a lack thereof. It's incredibly thin, like less than 1% of Earth's.
And it's mostly carbon dioxide.
Almost entirely KO Eros. So
No.
you can't breathe it. Obviously, you need suits outside, specialized habitats inside, always.
Okay, breathable air is out. What else?
Temperature, it gets unbelievably cold, especially at night. We're talking way, way below freezing. Survival requires constant heating.
Right, and then there's radiation, yeah.
That's a huge one. Earth's magnetic field and thick atmosphere protect us.
Yeah.
Mars doesn't have a strong global magnetic field and that thin atmosphere. It barely blocks any solar radiation or those nasty galactic cosmic rays.
So constant bombardment, not great for long-term health.
Not at all. And we haven't even mentioned the dust storms.
Ah, yes, the planet-wide ones.
They can be massive, lasting for weeks, blotting out the sun, which is a problem for visibility, for equipment, and especially for solar power.
Okay, wow. It sounds pretty hostile. Less welcoming frontier, more lethal environment.
That's a fair assessment without the right technology.
So let's talk tech. What kind of solutions are people working on? How do you even start to survive there?
This is where human ingenuity gets really fascinating. Habitats are key. People are exploring underground shelters.
To shield from radiation.
Exactly. Or using natural lava tubes, which Mars seems to have. Then there are advanced inflatable habitats, maybe easier to transport.
I read about 3D printing too, using Martian soil.
Yeah, using the local regolith. That's a really exciting area. Build structures right there. Plus, serious research into completely closed-loop biospheres. Think recycling everything. Air, water, waste.
Self-contained little Earths, basically.
Kind of. NASA's working on habitat concepts. Private companies like SpaceX are obviously pushing hard too.
Okay, shelter, radiation shielding, check. What about the basics? Water, food.
Water's interesting. You're pretty sure there's a lot of water ice, especially under the surface near the poles.
Frozen solid, though.
Right. So the challenge is extraction. You need powerful drills, heaters, systems that can work reliably in those harsh conditions. It's not like turning on a tap.
Definitely not. And food. You can't just plant potatoes in Martian soil like in the movies, right?
Not directly, no. The soil has perchlorates, which are toxic, so
Yeah.
probably greenhouses are the way to go. Hydroponics, growing plants in nutrient-rich water, no soil needed.
Makes sense. Any other food sources being considered?
Lab-grown meat is a possibility further down the line. Maybe algae farming. Algae are very efficient. And again, recycling waste back into nutrients is crucial. Nothing gets wasted.
Turning Martian waste into dinner. Got it. And you mentioned the co-Euro atmosphere earlier. How do we get oxygen? Bring it all from Earth.
Bringing it all is incredibly expensive and impractical long-term. Thankfully, NASA's MOXIE experiment, it was on the Perseverance rover.
Right, I remember that.
It actually worked. It successfully converted Martian carbon dioxide into breathable oxygen. Just a small amount, but it proved the principle. Scale that up, and you have a local source.
That's a game changer. Okay, so oxygen. Sorted, potentially. Power. Solar panels and dust storms don't mix well, you said?
They don't. So solar will likely be the primary source, sure, but you absolutely need reliable backups for when the sun is blocked or during the long nights.
Like what, batteries?
Batteries, yes, but probably also small nuclear reactors, like
Right.
the kilopower project NASA's been developing. Consistent power, regardless of sunlight.
Okay, the tech challenges are immense, but there are paths forward. What about the human element? Our bodies, our minds. How do they handle Mars?
That's maybe the trickiest part. Mars has only about 38% of Earth's gravity. Long-term exposure. We expect bone density loss, muscle weakening, similar to astronauts on the ISS, but potentially worse over years.
So you'd need intense exercise regimes, maybe artificial gravity somehow?
Both are being researched. Artificial gravity, like spinning sections of a habitat, is complex, but might be necessary for long stays or permanent colonies.
And mentally, being stuck in a small habitat millions of miles from home on a barren planet.
The psychological strain is a massive concern. Isolation, confinement, the pressure. It's extreme.
So what can be done? Therapy, virtual reality.
VR is definitely being looked at, creating immersive Earth-like environments to combat that isolation. Rigorous psychological screening and support systems would be essential. Training people for these extreme confined conditions is also critical.
Wow. Okay. So taking all this in, the environment, the tech, the human factors, when are we going, realistically?
Realistically, large-scale colonization isn't happening tomorrow, or probably even in the next 10 years.
Yeah.
The scientific consensus from the sources seems to be it's still a long way off.
So still more science fiction than fact for now.
For living there long term, yes.
Mm-hmm.
But the progress is undeniable. Look at the advances in rockets, reusable launchers thanks to companies like SpaceX. Look at the habitat experiments, the MOXIE results.
The building blocks are being put in place.
Exactly. Step by step, the usability increases. It's a monumental task, but
But humans are pretty good at tackling monumental tasks when we set our minds to it.
history shows that, doesn't it? That
Yeah.
drive to explore, to push beyond the horizon, overcome the impossible. It's powerful.
It really is. Well, this has been an incredible look at the science behind living on Mars. Thanks for diving deep with us.
My pleasure. It's a fascinating topic.
And for you listening, that question from our source material really sticks. If you had the chance, would you go live on Mars? Something to think about.
Definitely something to mull over.
Let us know what you think. This has been The Deep Dive, always trying to get to the heart of what's possible. If you enjoyed this, please like, share, and subscribe for more explorations.